Hello students, now we will see the machine learning approach towards solving a problem. Remember, all machine learning problems are posed as data problems. So you have to consider whatever may be the problem, that is to be considered as a data problem, and that data is always numeric data. The data is always numeric data. Your machine learning algorithm do not understand anything other than numbers. Got it? So whatever may be the problem, if you don't have numeric data, as a first step, you have to convert that non-numeric data into numeric data. Okay, so all problems are seen as the numeric data problems only, and the solution given by your machine learning algorithm to a problem is always in the form of a mathematical function. Okay, it is not, apart from mathematical function, it don't give anything else. Compulsorily there will be a mathematical, the output of your machine learning algorithm will be in the form of a mathematical function. That's why mathematical concepts like linear algebra, calculus, probability and statistics are very much important to us in understanding machine learning algorithms. What do you have to understand here? The solution to any machine learning problem is a mathematical function or a mapping between some input variables and the target, that is the output variable. There is a mathematical mapping between inputs and output. That is also called as a hypothesis, right? Unfortunately, initial data in majority of the machine learning problems, the initial data will be in the form of non-numerical data. The data will be some kind of non-numerical data. Most of the times we deal with cognitive tasks in machine learning, and those tasks deals with these kind of data where the data could be images, text, speech or video. This kind of data is called qualia or qualitative data. So a part of solving your machine learning problem deals with converting this qualitative input into numerical input. Okay, so the first step and the major step in machine learning is looking at the data, whether it is numeric data or not. If it is non-numeric data, by using some standard procedures in the literature, you have to convert that non-numeric data into, or non-numeric data is in general called as qualitative data. That qualitative data is to be converted into quantitative data. Quantity means numbers. Okay, so that is the one of the major portion of solving your machine learning algorithm. So converting images into numbers, converting text into numbers. If your input data is in the form of a speech, converting that into numbers. If it is a video input, it also has to be converted into numbers. And then your machine learning algorithm can only, it understands only the number, the data in the form of numbers. It can process the data which is in the form of numbers. So it establishes a relation between input and output. Again, that is a mathematical relationship. Mathematical relationship deals with numbers only, right? So at this juncture, you have to understand the importance of linear algebra in machine learning. In solving a machine learning problem or to provide input to the machine learning problem, always you have to have the numeric data, right? If you have non-numeric data, the data in the form of images, text, speech, and videos, that is to be converted into numbers, series of numbers, or sequence of numbers, or collection of numbers, which are called vectors. So, converting that non-numeric data into numeric data can be done with the help of linear algebra. In that manner, linear algebra plays a very important role and vital role in machine learning. So, many of the machine learning problems, the input and output are represented as collection or sequence or series of numbers that are called vectors. Here we have a data set. This is a very popular public data set, and it is a MNIST data set. The name of this data set is MNIST data set. It is a public data set. Anyone can use it. Okay. So, what this data set talks about? Here in this data set, we have some handwritten digits, and each and every digit is collected from some group of people. Okay, this 0 is not same as this 0. This is written by me, this 0 is written by you, and that 0 is written by some other person. Like that, from some volunteers, the handwritten digits have been, the images of handwritten digits have been collected and they have been taken. Right. So, remember, these are not a series of numbers. Each and every digit here is to be treated, or it is to be considered as one image. For example, you take this. That 5 is one image. This 8 is one image. So, images are stitched together. Okay. So, first of all, try to understand the data. These are not numbers. This is not numeric data. What I want to convey here is this data, whatever there in your MNIST data set, initially that is not a numeric data. That is the data which is in the form of image. For example, you take this 3. This is its corresponding images here like this. Okay. So, images stitched together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros are there. 16 zero images are there. 16 images of 1 are there. 16 images are 2 there. 16 images of handwritten 3s are there. Like that, from ranging from 0 to 9 for 10 digits, the handwritten digits corresponding images are there in your data set. So, what is your objective? If you are taking one such image, that image is to be converted into its corresponding numbers. How to do that conversion? In this data set, what is the input? Input is image. Your input is in the form of images in your data set, right? Now, among out of these 160 images that I have with me, I am taking one image. Okay. So, you have to convert this image into numbers. How can we do that? There is a classical approach. There is a standard approach to convert this into numbers. The idea is in image processing. Okay, the idea is simple. If you just look at the numbers that are ranging here, that is from 0 to 30 here, and as well in y-axis, as well as on y-axis, on x-axis also, the numbers are ranging from 0 to 30. So, what we can do here is, I am taking I am dividing the image into 30 equal portions vertically. Okay. Of course, it is not possible to draw 30 equal portions. It is a painful task. So just you imagine it. Okay. Similarly, 30 horizontal portions. Okay, like this, it is divided. So, how many cells we got here? 30 multiplied with 30, we got 900 cells. And look at the color that is there in each and every cell. Here, we have a specific name to that cell. A cell here is called, so if I am considering a cell here, the cell that is there here is called a pixel. The cell, one cell is called pixel. How many pixels are there for this image? How many pixels we have taken here? You can just as an example, I have divided it into 30 rows and 30 columns. You can divide it into 40 by 40 also. You can divide it into 50 by 50 also. Right. So, if you divide it into 50 by 50, the cell size further shrinks. Am I correct? Right. So, in this example, each and every cell is considered as a pixel, and you have to give a color coding to each and every pixel. Okay. And the range of that color code is always from 0 to 255. Let us say if my cell is pure white, then its corresponding code will be 255. If it is black, then its corresponding code will be 0. If it is light gray in color, from in between black to white, all the remaining shades are considered as gray shades. Actually, how many gray shades will present in between 0 to 250? In between black to white, we have infinite gray shades. But it is not possible to identify the intensity of each and every gray shade. Right? There will be a 0.000001 variation. It is not possible to go up to that level. Instead of that, what we are doing? We are dividing whatever the gray that is there, that is divided into 254 equal portions. Are you able to follow my idea? This is the standard procedure in which I am considering totally 256 color intensities. Among those 256 color intensities, 250, why 256? That is the standard procedure that the entire world is following. Okay, I have 256 color intensities in this grayscale image. Among those 256 color intensities, 0, the number 0 indicates black color. If any cell is completely black, for example, here you just consider this cell. In that cell, we have that cell is having only black color. So, you just mark that cell with 0. Okay, you take this cell, it is pure white. Mark that cell with 255. Let us take this cell. That cell is having a gray colored portion. It is gray in color. So, mark that with some number like 189 depending on the color intensity. So, while coming back to our grayscale understanding, out of 256, one is black and one is white. The remaining 254 are considered as gray only. The gray that is nearer to 0 will be obviously dark gray, dark to dark gray. The number that is nearer to 255, that is 250, 251, they are light to the lightest gray. Am I correct? So, in that manner, divide the entire gray portion into 254 equal portions, and depending on the color that is presenting in that specific cell, give the numbering. So I'm explaining that with another example. You just look at this image. This is the image of a famous personality, Abraham Lincoln. And in this image, if you look at it, there are different gray shades are there: dark gray, light gray, medium gray, as well as white and black. Okay, so if you look at his bird portion, black is dominating. Almost 4 black pixels are there. The corresponding numbers you check, 100. So black color, right? So in between, you just have the white portions that we have here at in these cells, that their value is always greater than 225 in this entire cells. And whenever we have gray, good gray, that is 164, 148, 100. So that means as the gray intensity is becoming light and light, the number, the corresponding pixel number is increasing. Did you understand the idea? So what we have taken here, just we pixelated the image, and for each and every pixel, its corresponding color intensity has been taken. Very simple idea, but a powerful idea. And then it is totally converted into set of numbers. So this is one column, second column, third column, like that. If I am considering the set of numbers for this image 3, we will get 900 entries. Am I correct? We are getting 30 rows and 30 columns. And associated with each and every cell, there will be one number, just like this here in this example. Now, this is the unique way of numbers. This is the unique way of representing this image in the form of numbers. Okay, so if you randomly disturb some 10 or 15 numbers here, then the shape of this image will be gone. Did you understand the point? For this image, this is the standard set. So if I am giving these numbers at any point in the world, we can come back to this image. The same idea is applicable to the images that we are taking from mobile phones also, but here it is not like 30 by 30 image. In our the HD image that we will take from our mobile phone is having 720 by 1080 pixels, 720 cross 1080. That means almost that number is 10. That is equals to 10 lakhs pixels. That is 1 million pixels will be there in one single image. Got the idea? So this is the way how we will convert the image into numbers. This is what we need here. Now your machine learning algorithm can understand this matrix. Got it? Your machine learning algorithm cannot process this image, but it can process these numbers. These numbers, this unique arrangement of these numbers is nothing but this image. Okay, you should not disturb the arrangement of these numbers. Even if you want to disturb the arrangement, there should be an orderly approach. Of course, here sometimes we have to disturb this arrangement. Here I have first column. The numbers that are there in the second column are to be placed below the first column, and the numbers that are there in the third column are to be placed below the second column. So that is called unrolling. Okay, so writing all the 900 values in a single column, that is called matrix unrolling. Sometimes we will use matrix unrolling. That is required. Why we need matrix unrolling? Here we don't have one such image. We have 160 images. For each and every image, we are getting 900 numbers. Right? First image, all the 900 numbers. Second image, all the 900 numbers. Third image, all the 900 numbers. Fourth image, all the 900 numbers, like that up to 160. All the 900 numbers are to be tabulated. Then that becomes your input to the machine learning algorithm. Your machine learning algorithm can process or it can play with those numbers. So this is the idea behind converting images into data. In a similar fashion, in the literature, we can convert even speech signal into numbers. Videos can be converted into numbers. Color images can be converted into numbers. Color images is just an extension of this idea. Whatever the color images that we have, those colors are to be converted into red, green and blue. Because RGB is the red, green and blue are the primary colors. That is primary color classification. Any color image that you have, that is to be divided into, filtered into its red, green and blue portions. Okay, for each and every portion, again you have to identify the colored intensities. For red color, 256 color intensities will be there. For green, 256 color intensities. For blue, 256 color intensities. And so again, here I am taking another example where this is the image, and in that image, the red color gives a separate matrix, green gives a separate matrix, and blue gives a separate matrix. See, I'll give you an interesting point here. I'll tell you an interesting point. If you look at this portion in this image, it is yellow in color. How to get the yellow color? Yellow color is obtained by mixing red and green colors in an equal proportions. So in this cell, for example, that cell is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is that cell is here, right? This is that cell, as well as at the same position in the green, same position in blue. In red, that value 65, and in green the value 65, and blue that value 0 gives this color. So what is the idea? By combining an appropriate color intensity portions of red, green and blue, you will get, but that means by mixing a certain color intensity portions of these primary colors, we will get the all other remaining colors in the world. That is the idea. Got it? So in this manner, any color image can be divided into 3 matrices. Earlier in grayscale image, you have only a single matrix. Here you are getting 3 matrices. So in this way, one more dimension has been added. Okay. So like that, if I have a color video, what is color video? Color video is nothing but a combination of color images. For example, by using my mobile phone, I want to record 1 second video. To record 1 second video, what that camera in my mobile phone will do? It will, the shutter in that camera will open and close for 24 times in 1 second duration. Are you able to get my point? If I want to get 1 second video, that 1 second video is obtained by 24 images in 1 second duration. My camera shutter will close and open and close for 24 times. So you are getting 24 images, right? Those 24 images are to be pulled together. That will be played for 1 second. So that comes as that gives you a feel of continuous playing, or that gives the feel of video. So in a way, video data is nothing but color image data. So how many images are there in 1 second? 24. If I want 1 minute color video, that will be 24 multiplied with 60, right? So the data complexity is increasing as we are changing from grayscale to color image to video image, right? So the numbers that are presenting here earlier, In this example, we have only one matrix in a grayscale image. Here in color image, we have 3 such matrices. Now, when time adds to it, for 1 minute duration or 1 hour duration, if I have to take the series of images, the duration will be considered as one more dimension. So a lot of mathematics is involved once you converted them into numbers. Now today's machines are really capable to handle such huge data. Okay, your GPUs and CPUs, very powerful machines with some special GPUs can handle this data. These kind of some millions of data are numbers in a very easy manner. So on processing those numbers, we will get the algorithmic implementation. So this is a very interesting idea. At ACE Engineering Academy, we have different customized courses that are exclusively designed for you. We have a pre-recorded course for GATE Data Science and Artificial Intelligence paper, which is a recently introduced paper. And a very important point, you scan the QR code and download the ACE online app, and you can access the content 7 days completely free. The advantage with pre-recorded courses is you can go as per your choice. Whenever it is convenient to you, you can schedule your study as per your convenience with the self-paced pre-recorded courses. Again, I am telling, you scan the QR code and download ACE online app. You will get 7 days free access to the content. Next, we have classroom coaching at Hyderabad for GATE, ESE and PSUs. And there is an exclusive online live classes are also there. By having the convenience of sitting at home, you can listen to the best lectures. So make use of all these variety of customized courses which will helpful for you in your preparation.